We're on the west coast of central Portugal at a town called Setúbal, and behind me is an area that has significant tidal differences. And the organisms that live in this area have to adapt to either airtime or water time. And so we have this off California where you have mussels and clams that live in these areas during the tidal variations. Now, other organisms have to deal with slow changes in the environment. This may come as sea level rise, a very slow thing that happens over hundreds of years or maybe decades. Or if they can manage, they have to deal with natural disasters like hurricanes or earthquakes or volcanic eruptions. Now, all the interaction that happens in these ecosystems is what we call ecology, the interaction between the organisms and their environment, and all the other things that are part of those ecosystems. So when we look at the historical record or the Paleo Ecology record that we see in geology, this gives us ideas based on what we know from the present as to what happened in the past. So now let's take a look at a spot in Western Australia with Steve Hasiotis, where he's been looking at the effects of a hurricane on that ecosystem.
Previous deposits of the De Grey River and Delta on the northwest coast of Western Australia, we see lenticular, glacier, and wavy bedding preserved in the cut bank of this river deltaic system. If you want to know how this formed, we just have to look at the modern processes going on here across this new cut through the gooseneck, which was attached to land, which is now isolated by the forces of Hurricane Zelia. What you see here are tidal waters going out at low tide, and at high tide they'll be coming back through, and you can even see those previous deposits from higher water. This is all part of a study of trying to understand how we can use processes of the present to understand processes and their results in the past. These bed forms in these rhomboid ripples going landward were produced by the tidal processes you see going on here. In this case, the tides are going out to sea, and this is low tide. You also see a large, fresh outcrop of modern sediment as a result of Hurricane Zelia, Category 4 storm that made landfall in mid-February. If you want to better understand the sedimentary processes and the major events or minor events that shaped them back then, we need to study them in present day settings. And in this case, we've been working the De Grey River for the last 4 years. And when this opportunity for Hurricane Zelia shows us that one-time major events can produce major changes in the landscape that you would normally think had taken hundreds of thousands of years to take place. This is a soldier crab. Soldier crabs live in these intertidal areas, particularly where it's dominated by marine salinities. And if you watch him dig, he digs and buries himself at the same time, and he does this to protect himself as well as for feeding on organics in between the sediment grains. As you see here, he's burying himself and will continue to move through the sediment, feeding and making a hollow tunnel and burrow through moving sediment upward and pushing sideways onto the wall of the burrow. When you see these deposits in the De Grey River, you wonder to yourself, was this laid down by marine processes or fluvial processes? Well, the answer lies in the types of trace fossils or burrows that are found there. And in this particular case, we're finding an abundance of trace fossils of fiddler crabs and of soldier crabs. In the De Grey River delta mouth, we see the pattern of traces and burrow opening that are very reminiscent of fiddler crabs. These fiddler crabs and the burrows of soldier crabs help identify these deposits as being marine influence through tides, particularly if we have found these in the rock record. So let's dig down and see if we can find the maker of the burrow. Let's open it up. And there he is. There's the fiddler crab. Very distinct, walking sideways. Two small chelae or claws, and then 4 pairs of walking legs. These are part of the decapoda. It's very diagnostic of intertidal marine settings. So in deep time, when we find similar burrows and similar pellets preserved, this gives us an indication that these sediments that later become rocks were made in tidal marine settings.